Hey, welcome back to Morals Math Corner. Today we are talking about definitions of trigonometric functions. We know that the trigonometric functions that we've worked with so far are sine, cosine, tangent, and its reciprocals. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Well, being that we know that, we can form what's called reciprocal identities. Since the sine and cosecant are reciprocals, then the value of the sine of theta is equal to the value of 1 over the cosecant of theta. So for example, if I were to tell you that the value of the cosecant of theta equals 3/4, what would the sine of theta be? Well, you could do this one of two ways. You could just know that it's a reciprocal, which is just 4 over 3, or it's sine of theta equals 1 over the cosecant of theta, which is still going to be state change flip 4/3. So that's how the reciprocal identities work. The cosine of theta is equal to 1 over the secant of theta. The tangent of theta is equal to 1 over the cotangent of theta. The cosecant of theta is equal to 1 over the sine of theta. The secant of theta is equal to 1 over the cosine of theta. And the cotangent of theta is equal to 1 over the tangent of theta. Yes, sir.
Just do like 1/4, but it's x is cosine or x is sine.
Okay, this is a question that he's asking from the previous chapter or section. Yes, sir. He asked, when I have this here, 1, 0, this is my x and this is my y. Yes, the x value is the cosine and the y value is the sine, sir. Excuse me.
The tangent of the unit circle is tangent equals sine over cosine. Right?
We're going to get to that identity in a second, but yes, the tangent of theta equals sine of theta over the cosine of theta, yes. But we're going to get to all that in a second. No, thank you. Okay, so let's go ahead and look at some examples here. For example, if I want to find the cosine of theta, the secant of theta is 5/3. So, the cosine of theta would be 3 over 5. Why are we all stressing out about this? It's a reciprocal. Done. Yes, sir. Will there be one that says to find the sine of the secant? No, because the sine is not a reciprocal of the secant. If they did do that, you would have to create a triangle first. Find the adjacent, the opposite, and the hypotenuse. And then you can find the sine from there, yes. But the sine and the secant are not reciprocals. What would the sine of theta be if the cosecant of theta is negative radical 12 over 2? So the sine of theta would be, very good, negative 2 over radical 12. And whoever said rationalize is perfectly right. Negative 2 radical 12 over 12, correct?
Negative radical 12 over 6.
Before you do that, let's think about it this way. Isn't the radical 12, isn't that made up of 4 times 3? So pull out another 2, so I've got negative 4 now. Radical 3 over 12, which equals negative radical 3 over 3. And that will be my answer. You okay, my brother? Yes? Okay. Now, when we are working with sines, and instead of saying it like that, when we are working with the trigonometric functions, there are going to be some quadrants where you're going to have to memorize the sine of that trigonometric function. And by sign, I don't mean the sign as a trigonometric function. I mean the sign as positive or negative. So I came up with all students take calculus. It isn't necessarily true, but it is for this class. So all students take calculus. All. In quadrant 1, all of the trigonometric functions are positive. All of the trigonometric functions are positive in quadrant 1. So I don't care the size of the angle. As long as it's in quadrant 1, it's between 0 and 90. Every single trig function will be positive. In quadrant 2, say students, with an emphasis on the S, only the sine and the cosecant will be positive in quadrant 2. Quadrant 3, take. Quadrant 3, take. T being the letter here of choice. Only the tangent and cotangent are going to be positive. And last but not least, calculus, C. Only the cosine and the secant are positive in that particular situation. So whenever we have a setup problem where they tell you terminal side of an angle is in the 4th quadrant, will the sign of that theta be positive or negative? Negative, because the 4th quadrant. Only cosine and secant are positive. If I have the terminal side of an angle is in the 2nd quadrant, the tangent of that angle will be positive or negative? Negative. I have the terminal side of an angle ends in quadrant 3. The cotangent of that angle will be positive or negative? Positive. Does that make sense? When in doubt, all students take calculus. Everything, all the trigonometric functions of the 1st quadrant are positive. S, students, 2nd quadrant, sine and cosecant positive only. 3rd quadrant, tangent, okay, take T, tangent and cotangent, positive. And 4th quadrant, calculus, C, cosine and secant are positive. Does that make sense, my brothers? Thank you. Okay, now, some more fun stuff to remember. Trigonometry is easy, but there's a lot to remember. When we're finding the values of the trigonometric functions, there are certain parameters that I must follow. There are certain ranges that are allowable. Remember, range being the y values. This relates more to how high it could be when you graph it. And basically, when you have the sine of theta, theta being the angle, the value of that theta, of that sine, must be greater than or equal to -1 or less than or equal to +1. So let's say that you have a sine of theta and it says that the value of the sine of theta is 3. Is that possible? No. Every single value of sine in the universe has to fall in between -1 and 1. So if I say the sine of theta is 0.7, that's possible. If I say the sine of theta is 1.7, it's not possible. Cosine has the same range. So luckily you don't have to memorize too many things. Yes, sir? Okay, I was just asked a question I don't understand. But is that like as in a fraction? I have no idea what that means.
Like it's the sine of theta is 3/5.
Okay, if the sine of theta is 3/5, then that means 3/5 is 0.6, and therefore it is between negative 1 and 1. Hopefully we know how to turn fractions into decimals. If we don't, it's very simple. To turn a fraction into a decimal, my friends, for example, 3/5, 5 goes on the outside, 3 goes on the inside, and that'd be 0.6. So the value of any sine of theta has to be between negative 1 and 1. So that means 0.9 or 9/10, or 0.5 or 1/2, or 2/3 or 0.67. Anything between negative 1 and positive 1. That is the same range for the sine and the cosine. Now the good news, the tangent and cotangent, the range is infinite. It's all real numbers. The tangent has no bounds because the graph of the tangent, just so you could visualize it, the graph of the tangent looks like this. And the graph of cotangent looks like that. Do you see how I keep going up forever and down forever? So that means all the possible y values are valid. Okay, it's forever. So the range for the tangent and the cotangent is all real numbers. Yes, sir.
Remember when it's like negative 1, 0, when we were doing that circle with students on the tangent?
Okay, so the value of the sine of theta and the cosine of theta has to be between negative 1 and 1. The tangent of theta and the cotangent of theta has no limits. All real numbers are the range. And now, the secant of theta can be either less than or equal to negative 1 or greater than or equal to negative 1. If you think about what my boy said over here, isn't secant the reciprocal of sine? So if sine is greater than or equal to negative 1 or less than or equal to negative 1, then doesn't it make sense that the secant is the opposite of that? It's the reciprocal? And then the cosecant is the reciprocal of the cosine. The cosecant of theta must be less than or equal to negative 1 or greater than or equal to positive 1. You had a question, my man? No, less than or equal to negative 1. I'm sorry if I misstated. Or greater than or equal to 1. Make sense so far? Okay, now. Yes, yes, yes? Okay, now. I want to know if these are in range. I tell you that the sine of theta is square root of 8. Is that in range? No! Because the value of the sine of theta must be between negative 1 and positive 1. If I tell you that the secant of theta is 0.6, no! The secant of theta must be less than or equal to negative 1 or greater than or equal to negative 1. I mean to positive 1. That's a no. How about the tangent of theta? Can the tangent of theta be equal to 110.47? Heck yeah, because it has no bounds. The range of the cotangent and tangent is all real numbers. Does that make sense so far? Okay. Go ahead and write that down, please. You got this down? Yes? Okay. Now, let me show you real quick before we break. What did I tell you? Let's start applying some stuff. Find the function values given. Alpha is in the second quadrant, and the sine of alpha is 2/3. Doesn't that mean that 2 is the opposite? Hello? Doesn't that mean that 3 is the hypotenuse? So don't go by the actual, what you see here in the squares. I'm just going to make a big triangle. So doesn't that mean that this is 2 and that's 3? So what would my x be? 9 minus 4 is 5, square root of 5. Negative square root of 5. Okay? Does that make sense? So now, we already have the sine. What's the cosecant of alpha? It's the reciprocal of the sine, so that's 3 over 2. What's the cosine of alpha? Adjacent over hypotenuse, so that's radical negative 5 over 3. What's the secant of alpha? It's negative 3 over the radical 5, which is going to be negative 3 radical 5 over 5. What's the tangent of alpha? Opposite over adjacent. So that's negative 2 radical 5 over 5. And what is the cotangent? The cotangent is adjacent over opposite. Does that make sense so far, my brothers? You sure? Now look real quick, and I promise I'll let you go. We're in the second quadrant, right? See how the sine and the cosecant were the other ones positive? What is the value of the sine here? 0.66, right? Is that in range? The cosecant of theta is 1.5. Is that in range? Yes. Go. Thank you. Hold on. All right. So, now let's finish up the lesson by showing you what's called the Pythagorean and division identities. These identities in the long run are going to make finding trigonometric functions easier, okay? I'm going to show you some tricks where you don't have to use it, but in the end, it's going to be a lot easier if you just remember these identities and know how they work. First of all, the sine squared of theta plus the cosine squared of theta will always equal 1. Sine squared of theta plus the cosine squared of theta will equal 1. So that means that the sine squared of 30 plus the cosine squared of 30 will equal 1. The tangent squared of theta, remember theta can be any angle, 10, 20, 30, 100, 90, whatever it is. The tangent squared of theta plus 1 equals the secant squared of theta, though. Sorry, I messed up. I apologize greatly. It's theta. Fool. Sorry. Okay, so tangent squared of theta plus 1 equals the secant squared of theta. Cotangent squared of theta plus 1 equals the cosecant squared of theta. And the tangent of theta equals sine of theta over cosine of theta. That's the division property. And the cotangent of theta equals the cosine of theta over the sine of theta. Now, go ahead and write these down. I know that some of you are looking at this and saying, uh-oh, this looks tough. Please don't stress. I'm going to show you how to work this all right now. I promise, okay? So don't let it stress you. Let's go ahead and see how this will work. I will keep the identities on the board. Okay. I want to find the sine of theta and the tangent of theta of alpha if the cosine of alpha is negative radical 3 over 4. All right, my brothers, check it out. We're going to use this guy. The sine squared of alpha plus the cosine squared of alpha, which is going to be negative radical 3 over 4 squared, must equal 1. So now, let's solve. I've got sine squared of alpha plus 3/16 equals 1. Sine squared of alpha equals 1 minus 3/16. That goes to 16. That goes to 16. So the sine squared of alpha equals 13 over 16. Take the square root of both sides. So the sine of alpha equals square root of 13 over 4. Done. Yes. That's how I find the sine. I'm going to do the cosine in a second, but you have a question, my man. What's up? Okay. What is the purpose of quadrant 2? Thank you. Great question. What is the, okay. It just gets so confusing when I say, what is the sine of sine? So why don't we say, let's see how we can differentiate this. Would this sign be negative or positive in quadrant 2? Positive. Is it positive? So I'm on. It's perfect. Now, let's find the tangent of alpha. Well, doesn't the tangent of alpha equal the sine over the cosine? So, tangent of alpha is going to be sine over cosine. State change flip. Tangent of alpha equals negative radical 13 over radical 3. But I have to rationalize, so this will be negative radical 39 over 3. Ding dong, the witch is gone. Now, talk to me. Yes. Thank you. Yes, sir. How did I get rid of the 4s? Okay. He's talking about this right here. Okay? He's talking about this right here. Okay? When you do that, okay, this part right here, you have stay, change, flip. So stay. Oh, I got to get rid of this. I'm sorry. Okay. So we're dealing with this, guys, right? Right here. I'm going to have to close this off, though. So I have stay, change to multiplication, flip. Stay, change, flip. Negative radical 13 over radical 3. But then you have to rationalize. Talk to me, brother. You're dividing fractions. Stay, change, flip. Thank you, my brother. Yes, sir. Of course I can scroll up, son. How about this? Want to make your life easier? No, you're welcome, son. Does that make sense? Okay, go ahead and write it down. And let me give you one more example, if you don't mind. Thank you, son. Let me know when you're done, brother. You got it? Thank you, son. All right, so let's go ahead and do one more. For example 6, it says, find sine of theta and cosine of theta if the tangent of theta equals 4/3 and theta is in quadrant 3. Okay? Let's think about this now. Let's think about this. I was given a tangent, correct? and I want to find the sine and the cosine. I can't use the sine of theta and the cosine of theta because I don't know what those values are. However, I can do, yes. Okay, what do you think you could do? No, well, yeah, yes. Good. We're going to use the tangent squared of theta plus 1 equals the secant squared of theta. Tangent squared of theta is going to be 4/3 squared plus 1 equals the secant squared of theta. So that's going to be 16/9 plus 1 equals secant squared of theta. That goes to 9, that goes to 9. So 25/9 equals the secant squared of theta. Take the square root of both sides. The secant of theta equals 5/3. Now, excellent, son. I was just told now you find the reciprocal. Excellent. If the secant of theta is 5/3, what's the cosine of theta now? And it is in the third quadrant, so actually, yes, this should be negative because all values are positive. The tangent and cotangent are positive. The rest are negative because in quadrant 3. Good job. So the cosine of theta would be, it's the reciprocal, guys, so negative 3/5. Right? You with me? Now I have the tangent, okay, and I have my cosine, correct? That's going to be a little bit too long in my opinion. What I would do in this case is go sine squared of theta plus cosine squared of theta equals 1. So I got the sine squared of theta equals 1 minus 9/25. So that's a sine squared of theta equals 16/25. So the sine of theta equals 4/5. So you got your sine, you got your cosine, and there's the whole problem put together. And the sine, wow, yes, good job. And the sine should be negative as well. Maybe I should learn how to pay attention. Everything in quadrant 3 is going to be negative except for the tangent and cotangent. Way to go, kid. You were paying more attention than I was. Thank you. Yes, sir.
All right, so we wouldn't really know if it's negative until you like what's the name?
Yes, sir.
We wouldn't know if it's negative until after you figure it out and then look at the quadrants.
Yeah, as far as putting the signs in, yeah, just be sure to pay attention. Unlike Mr. Morrow, this said that theta was in quadrant 3. I just went ahead and did it without thinking. And that's where the problem comes. That you need to think. So I messed up, and I have no excuse for that. So I apologize. Take my mistake as a learning experience. Always reference back to the quadrant. Does that make sense? You sure? Okay. Thank you very much. Have a good day. We're done.